In this experiment, you'll investigate the concept of measurement uncertainty by repeatedly measuring the velocity of a battery-operated car. Here we have a meter stick. This battery-operated car is designed to move at a constant velocity without accelerating. If we release the car so that it travels the length of the meter stick, we can measure the time this journey takes and use it to determine the velocity. It's common practice to measure the same quantity multiple times in order to confirm the result. We don't expect to get the same result every time because many minor random factors will influence our measurement every time. However, we do expect that the numbers should cluster around some central value. If we take all our measurements and divide them up into little ranges, we can plot them on a bar graph like this. This is called a frequency histogram, and we can see that when we're measuring a single value, it has a bell curve shape. This is also called a Gaussian distribution. The peak in this bell curve is the average or mean of the distribution. We can also find this by adding all the measurements together and dividing by the total number of measurements. The width of the bell curve shows how tightly packed our values are. We can also calculate this using a formula called the standard deviation. As we take additional measurements, the mean value can move around. And although it moves around less the more measurements we take, we can never arrive at the true value. We can also start to fill in this bell curve, but we'll never end up with a completely smooth Gaussian distribution. We can, however, calculate the uncertainty in our average by dividing the standard deviation by the square root of the number of measurements. In many disciplines, this is called the standard error or standard deviation of the mean. Measure the velocity of the car in each of the trials in this video, and use the results to answer the questions at the end.
Let's ask ourselves some questions about how we should analyze this data. Why can't we just take one measurement of the time it takes for the car to travel from one end of the meter stick to the other and divide by 1 meter to get the velocity? Is it more accurate to take an average of all the times, or is it more accurate to calculate the velocity in each trial and then average those values? Can we just combine the data from when the car went to the right versus when the car went to the left? How could we check to see if it's all right to combine that data? Should we throw out the data from the time when the car knocked the ruler over? When is it all right to discard data? These are all good questions to ask when you're analyzing data and can help you understand what's going on in your experiment. So think about all those things as you're analyzing your data.